Good morning, class. We are looking at Module 4, covering chapters 8 and 9. Here's chapter 9, Inferences from two samples. So we are continuing with the test of hypothesis dealing with two samples. Among 843 smoking employees of hospitals with the smoking ban, 56 quit, smoking 1 year after the ban. Among 703 smoking employees from workplaces without smoking ban, 27 quit smoking a year after a ban. Is there a significant difference between the two proportions? Use a 0.01 significance level. So it's important to write the given. We are dealing with BD, binomial distribution, because there are two outcomes. Either they quit or they don't. So the first place, N sub 1 is 843 and X sub 1 is 56. The second place, N sub 2 is 703 and X sub 2 is 27. And we are interested in the test of hypothesis with alpha being 0.01. So that's the given. So there are some formulas we need to know. P bar, the proportion, is X sub 1 plus X sub 2 over N sub 1 plus N sub 2. And the Z, which represents the sample statistic, is P1 hat minus P2 hat over the square root of P bar Q bar over N1 plus P bar Q bar over N sub 2. Again, you can find it in your formulation. So let's calculate what we need so we can use these formulas. For example, we need P1 hat, P2 hat, P bar, and so forth. So P1 hat X is X sub 1 over X sub 2. 56 over 843. P2 hat is X sub 2 over N sub 2. 27 over 703. P bar is the sum of these two numbers, X sub 1 and X sub 2, divided by N sub 1 plus N sub 2. That means add these two numbers, 56 and 27 in the numerator, 843 and 703 in the denominator. That's your answer. And we need Q bar, just as before. Q is 1 minus P, therefore Q bar is 1 minus P bar. Q bar is 1 minus P bar. Just write this. So very straightforward. Let's move on with the first step. H0, P1 minus P2 equal to 0. And you could write P1 is equal to P2. It has the same meaning. Is there a difference between the two proportions? It's not saying less than, greater than. So P1 minus P2 is not equal to 0, makes it a two-tailed test. And let's make that a claim. And again, just to make sure we understand, this is absolutely perfect. P1 minus P2 is 0. H0. H1, P1 minus P2 is not equal to 0, which makes it a two-tailed test. That's why. Why is this a claim? Is there a significant difference between the two proportions? We're going to make this a claim. Again, one way to write it would be as follows. We could have written P1 equals P2. P1 is not equal to P2. Please don't mix them up. If you go with this, you must go with that. Test statistic as a formula that we have up here. So we are going to put all these calculations we've done into that. P1 hat 0.0664 minus P2 hat 0.0384 over the square root of P bar Q bar over N1 P1. P bar is 0.0537, Q bar is 0.9463. over 843 plus the same thing over 800, 703. So this actually is this is 703, everybody. I want to make sure that we have that taken care of. And we have the test statistic. Critical value comes from the choice of alpha. Alpha is 0.01. We go with the Z table. It's a two-tail test. So total is 0.01. In each tail is half of it, which makes it 0.01 divided by 2, meaning 0.005. So Z is plus minus 2.575 from the table, technology, you name it. To make a decision, we need to see where we end up in a matter of comparing these two. So graph is a must. Notice Z is negative 2.57. So to the left of it is a critical region, okay? Rejection region. It's also 2.575 to the right of it is a critical region, rejection region. In between is a non-critical region or NRR, non-rejection region. We locate test statistic 2.4319. It's somewhere here, way into the non-rejection region. So fail to reject the null hypothesis. Fail to reject the null hypothesis. So now let's expand the concept to the claim. So if we are not rejecting H0, what are we rejecting? H1. And therefore we are rejecting the claim. The claim becomes false. And we just reword as follows. There is not a significant difference between the two proportions, so there is not sufficient evidence to support the claim that there is a significant difference between the two. So again, very straightforward, everybody. Let's look at the technology. We use two proportion z-test, stat test, two proportion z-test, and we need to put n sub 1, n sub 2, x sub 1, x sub 2, and figure out the type of tail. So look at what we put. X sub 1, 56, n sub 1, 843, x sub 2, 27, n sub 2, 703. So that really helps here. And P1 is not equal to P2. That makes it a two-tail test. You do the calculation. As you do the calculation, here's what you notice. These are the important parts. So this is P1 hat. It's been calculated for us. This is a P2 hat. It's been calculated for us. And this one is a P bar. This last one is P bar. And it's been calculated for us. The only thing I want to make a point of, there's a slight difference due to the number of decimals they use. Okay, due to the number of decimals that they use. But if you stop here, this changes to 7, right? Just like this. Also, you notice, so that's P2 hat, and that's the P bar in order. You notice this number. This is the P value, which is 0.01492, and way larger than the choice of alpha of a 0.01, and we fail to reject the null hypothesis. So we have the same decision as expected. I'm going to continue with the same question. The second part is asking for confidence interval. Construct 99% confidence interval. Same question, everybody. And here's the information we gathered from the previous page. The formula is similar to what we have seen for a one sample. P1 hat minus P2 hat plus minus E. That's the idea. So P1 minus P2 is between these two values. And when you want to write it, you want to see how they want it. They want it in this format, or they want it in this format. Two different formats. I'm going to erase that in a moment. But this format versus this format, you want to be very careful with that. So all we have to do, calculate the E, because we have P1 hat and P2 hat. It's easy to subtract one from the other. And E has the formula similar to what we have seen for a one sample, which is Z squared of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Take a look at this formula. All you have to do, plug in the numbers here. And because this is a 99% confidence interval with alpha being 0.01 for the test of hypothesis, since these two numbers, 0.99 and 0.01, they add up to 1. That means 99% confidence interval, and two-tailed test with alpha 0.01 are equivalent. And therefore, you use the same z-score. By any chance, if alpha was 0.01 and this was somehow a one-tailed test, this should have been 98% to correspond to each other. So we use the same thing. So let's plug in the values. We have the z-score, P1 hat, Q1 hat, N1, N2, and it results in 0.0289. So the most important thing is to let your reader know what formula you're using. The given will make it easy to calculate. And so it's P1 hat minus P2 hat plus minus this. So what is P1 hat minus P2 hat? The difference between these two numbers. And now we are going to subtract this from it and add to it. And results in the following. P1 minus P2 is between these two numbers. Now, let's see how we compare test of hypothesis with the confidence interval. This confidence interval contains 0. It goes from negative to positive. Therefore, because the confidence interval limits contain 0, there is not a significant difference between the two proportions. Fail to reject the null hypothesis. It gives you the same result. All right, if we were to use technology, for example, TI confidence interval two proportions, notice we put x sub 1, n sub 1, x sub 2, n sub 2, the confidence level of 99%, we do the calculation, it results in the following, and take a look at what we are interested in. Of course, this stuff is again calculated, but this is the confidence interval. And this is what we did. The right side is easy to see. The left side, this is again scientific notation, which means -9 times 10 to the power of -4. I want to make sure we understand what that means. So this means -9 times 10 to the power of -4. That means the decimal is here. Move it this way 4 places. That's the meaning of it. So you should be able to understand that. And as you can see, if I stop here, 8 changes to 9, becomes identical. So they're close. again, the difference is due to the fact that calculator does a better job with a lot more decimals. Company A claims that its yogurt cups contain, on average, fewer calories than that of a competitor. A sample of 50 such yogurt cups, Company A produces an average of 141 calories per cup with a standard deviation of 5.4 calories. A sample of 40 yogurt cups of a rival company B produced an average of 144 calories per cup with a standard deviation of 6.3 calories. If the calories of the yogurt cups for Company A and Company B have different variances, use a 0.01 significance difference to test the claim. I'm going to discuss that concept in a moment. But so what happens is we have to write the given as always. So what is given? We set up this table to make life easier. And for Company A, we would call it N sub 1 would be 50. For Company A, we would call it X sub 1 because we have two different companies. On the average, X1 bar, this is X1 bar is 141 and S sub 1 is 5.4. We do the same thing for the second one. Proper numbers. Now, for part A, we also have alpha equals 0.01. So that's given. This is just reading the information. It's the given. Now, this tells you what formula to use for test statistic input. There are two different formulas, whether you assume different variances or equal variances. And if it's not mentioned, you have to assume different variances. So H0 mu1 equals mu2. Remember, with H0, the null hypothesis is always equality. And H1 would be what? Let's see what's the claim. Is the claim that the yogurt contains average fewer. So that's the key. So H1 mu1 is less than mu2, and that's the claim. That is the claim, everybody. Needless to say, it's a left-tail test. By the way, again, this is perfect. One could write mu1 minus mu2 is 0. Mu1 minus mu2 is less than 0. Okay, as long as you're consistent and pay attention to the way they want you to write it for 4 credit. The next step is to calculate the test statistic. Here's the formula for test statistic, similar to one sample, x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. And again, you have all the information here, just plug in. That helps. This is extremely important to write. So plug in. So again, what is the meaning of different variances? It is telling you to use this formula because there's a slightly different formula if you assume equal variances. And normally we don't assume that. You plug in. By the way, as far as the formula in some text, you see that over here they have mu1 minus mu2, which comes from h0 and becomes 0. That's why I wrote it in that format. So the formula may have x1 bar minus x2 bar in a parentheses minus, let me just write that. In some text, you will see the formula in the numerator is x1 bar minus x2 bar minus mu1 minus mu2. And that's why I used 0 to mention that. This always comes from H0 and it's always. So anyways, you do the math, that's what you get. The next step is the critical value from the choice of alpha equals 0.01. And because you're dealing with a t distribution, the reason is because sigma is missing, of course. You go with the degrees of freedom. And the way in this case using table is used, we go with the smaller of the two. This is N1 minus 149. This is N2 minus 139, and the smaller is 39. And from the table, we get negative 2.426. And with that being the case, when we do the drawing, it's extremely important to see why and how we make a decision. If you look at this graph, alpha is 0.01. The critical value is negative 2.426. For t, test statistic, which is negative 2.309, is somewhere here. And it may not be to scale, but it's way into the non-rejection region. Therefore, don't reject H0 or fail to reject H0. Now you go back to the very first step to make a decision about the claim. If you don't reject H0, what are you rejecting? H1. Therefore, you're rejecting the claim becomes false. And you rewrite this statement. There is not enough evidence to support the claim that company A's yogurt cups contain on average less calories than that of its competitor. We're going to continue with the same question. Part B, calculate the p-value for the test of a previous part and make a decision. Is this decision in agreement with the previous one? Here's the information from the previous part. Here's the alpha. Here's the degrees of freedom. Here's the t minus 2.426. And here's the t table. And according to the p-value, the p-value is area to the left of test statistic, meaning, first, please understand this is alpha. So in traditional method, you compare two numbers, the critical value versus test statistic. With the p-value, we compare two areas. This area is alpha. This area, which is of course larger, is the p-value. Of course, you don't know that when you do it with the technology. The reason they go with the p-value, they don't give you the critical value. So they just give you the area. And so with that being the case, if we want to go with the table, the number, of course, you make it because the table gives you positive values only. On the left column, you look for number 39 because that's your degrees of freedom. And within the given numbers, inside, you look for this number positive. 2.3901 doesn't exist, but it's between these two numbers. So therefore, for the area in two tails is between these two. For one tail, it's between these two. And we had it for one tail. So it's somewhere in between. And therefore, for area and one tail, it's somewhere in between. So here's how we write it. When the degrees of freedom is 39, the test statistic of negative 2.3901 is somewhere between these two numbers. And therefore, the area in one tail is somewhere between these two numbers, according to the table. And remember, alpha is 0.01, so a number is between the two, therefore make it larger than alpha of 0.01. And we have the same decision, fail to reject the null hypothesis. Decision is an agreement. And we're done. You can do this by technology. How does it work with technology? We go with two sample t-tests, stat test, two sample t-test, and we put the information, and we choose right tail, left tail test, and it's asking you whether you want to pull or not. That means you are assuming equality, and the answer is no. And that is important to pay attention to. Now take a look. So you can use data if data is given, or in this case, we're going to use stats, x1 bar, s1, n1. x2 bar, s2, n2. You choose less than because of the left tail test. And is it pulled? You say no. So take a look at all of this, the way you input, and look at the result. What do we notice? Okay. Calculated results are different since degrees of freedom has a different value. Take a look at the degrees of freedom here versus degrees of freedom here. This is the degrees of freedom because the degrees of freedom uses this very complicated formula. And if you want to go with that, 77.1146, it's very hard to find the value. And normally this is not as different, but here's the formula: a plus b quantity squared over a squared over n minus 1 plus b squared over n2 minus 1, where a is s1 squared over n1, b is s2 squared over n2. You don't have to worry about that. The calculator has done the degrees of freedom for you, and the p-value is that. And now the result is different because the p-value, which is 0.009642, is less than alpha 0.01. Needless to say, it's almost the same because if you stop here, it becomes 0.01. And you reject H0. So again, I can't emphasize this enough. For the case that you do not assume equal variances, so you go with different variances, the degrees of freedom will be different. And it's pretty difficult to calculate that. By the way, of course, this one is the same test statistic that has been calculated, very close to that. I mean, it may not be identical, but it's close again. And I hope it's clear to everybody. All right, we continue with the same question. We want to make a 98% confidence interval. Now, remember, alpha is 0.01. It's a one-tail test. It doesn't matter left tail test or right tail test. For confidence interval, remember, if you have 0.01 on the left, you have 0.01 on the right, and then 98% in between. So 0.01, alpha 0.01 correspond to 98% confidence interval. Again, alpha 0.01 for a one-tail test. Left or right makes no difference. So, and again, we have written the information from the previous page. It's similar to what we have seen. It was x bar plus minus e for one sample, for two is x1 bar minus x2 bar plus minus e, and this is easy, of course. Now, what is the formula for e? I want you to pay attention to that. Now, this is a very easy calculation if it's done by hand, because this comes from before the critical value. So we put 2.426, of course, the positive value. And this part, if you go back to this, you notice the denominator of your test statistic is identical to this value. And I'm going to remind you that test statistic had this formula, and this was the denominator. I don't have to evaluate it again. So T alpha over 2, I already have it. And this one is the denominator of test statistic. So again, makes it very easy. I want to show you how calculation becomes easy as long as you pay attention to that. And so now, here's the answer. So x1 bar minus x2 bar, if you look at the formula for the numerator here, this is x1 bar minus x2 bar. So minus 3 plus minus this number. So mu1 minus mu2 is between negative 6.04504 and 0.04504. Clearly, one is negative, one is positive, so it contains 0. Because the confidence interval limits contain 0, there is not a significant difference between the two means. Fail to reject the null hypothesis. If 0 is in between, that means equality in essence. Go for the equality, go for H0. Fail to reject the null hypothesis. Let's do technology. We're going to do two sample T interval, and we're going to put the information. And again, pull now, take a look. So we put x1 bar S1, N1, x2 bar S2, and do confidence level is 98%. Are you going to pull no? And take a look at this answer. And I want you to pay attention again to the degrees of freedom, which is different than what we had assumed. And that's why the discrepancy. In this case, both sides are negative. Okay, note calculated results are different since df has a different value. Remember, degrees of freedom we said is 39, smaller of the two when we do it by hand. This one is a more precise one, and there's actually a huge difference between the two. Sometimes it doesn't happen, but in any event, because the confidence interval limits are both negative, in other words, both have the same sign. If they are both negative or positive, means the same thing. Both have the same sign, in this case negative, and do not contain zero. That's the key. Do not contain zero. There's a significant difference between the two, means reject the null hypothesis. So, in short, if the confidence interval contains zero, fail to reject the null hypothesis. If it doesn't contain zero, doesn't matter both negative or positive, reject the null hypothesis. That's how they agree with each other. And again, this had a discrepancy. Now, same question, if the calories of the yogurt cups for company A and B have equal variances, repeat the previous question. So we're going to do the same question with the same information. Alpha is the same, but this time we are assuming equal variances, and basically it uses a different formula for the test statistic. The first part repeats, identical, mu1 equals mu2, mu1 is less, h1 mu1 is less than mu2, claim and left tail test. This is identical to the previous part. What is different is this T has the formula x1 bar minus x2 bar over the square root of s sub p squared over n1 plus s sub p squared over n2, and s sub p is the pooled sample variances. So how do you calculate that? N1 minus 1 over S1 squared times S1 squared plus N2 minus 1 S2 squared over N1 minus 1 plus N2 minus 1. So the average weight of the variance in essence. And so we have all the information here, plug in and calculate S sub P squared. 49 times 5.4 squared plus 39 times 6.3 squared. Add these two numbers, and the result is 33.8267. Remember, we want SP squared. You don't have to take a root. We just use that number for both cases. And so test statistic using that. Following the formula, of course, the number in the numerator, as you remember, it was -3. The same thing happens here. And we get the test statistic of -2.4316. And the next step is the critical value with the choice of alpha of 0.01. Degrees of freedom add up. That means 50 minus 1, 40 minus 1, they add up to 88. Now, as far as 88 is concerned, you have to use 88 and technology will give you the answer. As far as the table is concerned, normally they don't have it. When they don't have it, you go to the closest one, which is 90. But again, technology can handle that. Table can't. Normally they can. So if we go with the table, and we're going to go with 90 instead of 88, we get -2.368 because it's a left tail test. Let's go with the graph to help us make a decision. Here's the t-test. Here's the critical value, t equals -2.368 and alpha of 0.01. Test statistic is -2.4316, is smaller than that. It's way into the rejection region. I hope you can see that clearly. So clearly reject H0 because the value of test statistic is inside the rejection region. So if you're rejecting H0, let's go back to the first step. You're rejecting H0, loosely put, you accept H1, you accept the claim becomes true. And you rewrite it. There is sufficient evidence to support the claim that Company A's yogurt cups contain on average less calories than that of its competitors. We are going to continue with the same question, finding the p-value and make a decision. And remember, 88, we went with 90 roughly. And degrees of freedom is 90. The test statistic is negative 2.4316. I refer you to the table. Go ahead and look at the t-table when you have time. It's between this number doesn't exist, and it's between these two numbers. And therefore, the p-value is between these two numbers, area in one tail. And no matter what, it's less than a 0.01. We have the same decision, which is rejecting H0. Let's go with technology. And as you notice, everything is the same as before, except here, where it says port, you say yes, because we are assuming equal variances. When we do that, X1 bar, S1, N1, X2 bar, S2, N2, mu less than mu2, and pull yes, calculate, and notice what we get. The p-value, the degrees of freedom is what we have, 88. And the p-value is this number, 0.0085. If we stop here, 85, which is less than alpha. And it gives us the same decision. And by the way, this number, negative 2.431, is the one we calculated, the test statistic. Or you can look at this one, it's easier this way. Test statistic that we did calculate. Very straightforward. So in this case, everything works out. Let's look at the 98% confidence interval. And again, information from before with all of this. We are interested in calculating x1 bar minus x2 bar plus minus z. Again, I remind you of this formula, and therefore what we had here, it makes it easier. Recall that for the test statistic, we had this. In other words, a lot of things is already calculated. We have the critical value. So for this one, we have the critical value. For this one, we have the denominator from the previous page. Take a look. These two. Very straightforward. That makes calculations a lot easier. 2.9216. And so remember, the numerator is x1 bar minus x2 bar, so minus 3 plus minus this number. And mu1 minus mu2 is between negative 5.9216 and negative 0.0784. Notice both of them have the same sign, meaning both of them are negative, and the confidence interval limits doesn't contain. The limit does not contain 0. So because the confidence interval limits do not contain 0, there is a significant difference between the two means. Reject the null hypothesis. As long as they have the same sign, negative or positive makes no difference. 0 is not in there. Let's go with technology again. Two sample T interval. Take a look. You put all the information as before, and again, pull. You say yes. Confidence level, 98% or 0.98. Take a look at this number. And take a look at this number. Very close. Again, the difference is because we use a lot more decimals with calculators, but very close. Test a claim that weights of male college students have a larger variance than female college students. Use a significance level of 0.05 and assume the populations are normal. Alpha is 0.05. So in this case, it's given for males, for females, and alpha is 0.05. Now, I got to tell you what we use here is known as F table, F distribution. It's a very limited table, and it's skewed to the right, and it's all positive values. The way you choose which group is the first one, pay attention. The one which has a larger S or S squared. This one has S28, this one is S25. This is your first group. If this was larger, by choice, this would be your group. I'm telling you right now, you want to pay attention to that. The one with the larger standard deviation is your choice of being the first group. So we write normal distribution, alpha is 0.05, males would be the first group because S is larger. And you say N1, 31, S1, 28. Females would be the second group, N2 is 29, S up to is 25. So the larger the standard deviation, that would be make it the first group. All right, so how do we write the first step? 3 different ways, and I want you to understand this. We can write sigma 1 squared equals sigma 2 squared because we are using a significance of 0.05, and so the population, the weight of, okay, we are dealing with the variance. So test the claim that college students have a larger variance. So that's what you do. Sigma 1 squared is larger than sigma 2 squared, which makes it the right tail test and claim. By the way, it's always right tail test. That's why if you choose this accordingly, it becomes a right tail test. The second method, so either this one or these two, you can say sigma 1 squared over sigma 2 squared is 1. Sigma 1 squared over sigma 2 squared is larger than 1. This is the second method. Or you can choose sigma 1 equals sigma 2 and sigma 1, or sigma 1 is larger than sigma 2. Please don't mix them up. 1, 2, or 3. One of these 3. Which one do you use? The one that they want you to use. But they all mean the same thing. Now, test statistic is very simple. S1 squared over S2 squared. And it must be positive. That's why we go with the first group having a larger value. If this number is less than 1, you've made a mistake. Make sure you choose the larger one at top. So 28 squared over 25 squared. And that gives you 1.2544. The next one is the critical value. Alpha is 0.05. And it is a right tail test. So the entire area is in the right. So you look for degrees of freedom, but there are 2 of them for the numerator and the denominator. For the numerator, 31 minus 1 is 30. For the denominator, so this is the numerator, this is the denominator, it's up to 29 minus 1 is 28. So when you have those two, you have to go with the F table. There are various F tables, and with the F tables come the choice of alpha. They will give you, if you go with the technology, it makes it easier. You go with the table, alpha is 0.05, 0.01, 0.1. The ones that they have, make sure you choose the proper alpha. Then you have this row that is degrees of freedom for the numerator. And for the numerator, we are looking for number 30. And then you have this column. Of course, I didn't have room. There's only one of them. And we are looking for 28. So we put the two together. And the result is F is 1.8687. So again, to recap, the F table, there are a few of them. Choose the proper alpha. In this case, our alpha is 0.05. Degrees of freedom of the numerator is in the top row. The denominator is the left column. Put them together and the answer is F. Now do the drawing. This area is 0.05. This critical value is 1.8687. And the F that we have calculated is somewhere here. Remember, this goes from 0 to infinity, skewed to the right. And therefore, we are way into the non-rejection region, and we're going to say fail to reject the null hypothesis because the value of test statistic falls in the non-rejection region. And the next step is if the claim is true or false. If you fail to reject the null hypothesis, you accept H1 and the claim becomes true. My apologies, fail to reject the null. You are not rejecting that, you are rejecting H1, the claim becomes false. So there is not sufficient evidence to support the claim that weights of male college students have a larger variance than female college students. We're done. Let's look at technology. We go with two sample F test. When we do that, we need to put S1, N1, S2, N2, and we are going to go with larger than, and then calculate. And it gives you that. Notice what you have. You need two pieces of information. You need to calculate the test statistic. It's the same as ours, very straightforward. And you need to know the p-value. Take a look at the p-value, 0.27, because they don't give you the critical value. They give you the p-value. And it's way larger than alpha of a 0.05. And you have the same decision, fail to reject the null hypothesis. And therefore, the claim is false. Directional asymmetry, or DA, is a phenomenon whereby in a population, one side of each organism is consistently larger than the other. For example, left may be larger than right. And evolutionary biology studying DA measures the length of the left and right wings of a sample of Drosophila, a type of flies whose members are often called small fruit flies, collected from nature, and she gets this data. So this is the information. The first one, the left wing, the right wing in millimeters, the second one, the third one, so on and so forth. So this is the collected data. Part A, the researcher decides to perform a two-sample t-test to determine whether the mean wing difference differs between the left and right sides of these flies. What type of t-test will she do? Where alpha is 0.05, and part B, find the 95% confidence interval for the difference between the means. Obviously, we do the paired t-test. That means we calculate the D difference. D is the difference between the two. So it really doesn't matter left minus right or vice versa, as long as you're consistent. If it's right minus left, you just keep up the same. So in this case would be 1.34 minus 1.26, which gives you 0.08 millimeters. And you do the same thing here. 1 minus 1.28 gives you negative 0.28. And you do exactly the same for the rest. So we need to calculate the difference. We do that. Then what happens? D bar is summation of D over N, S sub D summation of D minus D bar quantity square over N minus 1, and so forth. And I hope you see that if you assume this is X, is the same formula for X. So we use TI calculator, stat, edit, clear list L1 and L2, and then we get to L1 minus L2 stored in L sub 3. This is how you calculate this, nice and easy. And so not only it calculates that, it gives you the D bar with a bunch of decimals. So the average for this column, standard deviation for this column. And how many do we have? Any 17. So you don't have to do this by hand. You need to know how it's done. All right. So the very first step is H0 mu sub D equals 0. And we want to see whether they differ or not. So mu sub D is not equal to 0, which makes it a two-tailed test with a claim. So let's look at calculations and formulas. If you look at this formula, think about a T that we learned about. X bar is X bar minus mu of X bar over S over square root of N. So in essence, you can really run that test on the difference and it works exactly the same. So that's why this formula is practically the same as the formula X bar minus mu over S over square root of N. You plug in and it results in negative 1.636. A critical value comes from the choice of alpha, degrees of freedom of N minus 1. And from the table, we get plus minus 2.120. We've done this many times by now. So we go with the graph in order not to make a mistake. The critical value is negative 2.120 here and positive 2.120 here. And here's alpha over 2. Remember, alpha is 0.05 divided by 2. So in each tail, we have 0.025, half of that. And this is the middle, the non-rejection region. A test statistic of negative 1.636 is somewhere here. It's way into the non-rejection region. Do not reject H0. If you're not rejecting H0, whether you're rejecting H1, the claim becomes false, and you rewrite it. There is not sufficient evidence to support the claim that the mean wing differs between the left and right side of these flies. Therefore, she cannot conclude that this population possesses DA, directional asymmetry, because the mean lengths of the wings on the left and right sides do not differ significantly. If you were to do it by technology, you would use matched t-test data, and basically you put the t-test and you plug in the information. If you want to go with the data, remember mu sub 0 and list L sub 3 is L1 minus L2. Choose right tail test, two tail test, or two tail test, calculate. Does the job for you. You can try it on your own. I'm going to continue with the same question. In part B, we want to find the 95% confidence interval. And we are writing the information we have from the previous page. And remember, it's a two-tailed test with alpha of 0.05, alpha of 0.05, which is the same as confidence level of 95%. So we already have the information, 95% confidence interval. We have the critical values plus minus 2.120. So we have all the information. And in this case, we are going to use D bar plus minus E. By the way, on purpose, sometimes I use lowercase, sometimes I use uppercase. It depends on the text. Sometimes they use lowercase, sometimes they use uppercase. So be familiar with that. And E, I hope you remember that for X bar was T S over square root of n. It's the same thing in essence. And so we have the T, which is this number. We have the S, which is this number, and a square root of n, which is 17. So it gives us 0.1174. And a D bar, which is this number plus minus this number. Again, this is one way to write it. And the other one is that mu sub t, subtract this number from it, put it on the left, add to it, put it on the right. As you can see, it contains 0 because we go from negative to positive. Since 0 is contained in the interval, the decision is to not reject the null hypothesis mu sub d equals 0. It's important to know what happens then. Okay. Let's look at the technology. You can use matched t interval and put the data and the same thing and calculate. You can do it on your own. An ecologist is concerned with whether pollution entering part of a preserve area is compromising the health and growth of an endangered species of snake. To determine this, he decides to measure the length of a set of mature adults from the polluted area, polluted, and an unpolluted area. The researcher decides to perform a two-sample t-test to determine whether the mean length of this snake differs between these two areas, with alpha being 0.05. So gathers some from unpolluted, how many? 15. Some from a polluted area, how many? 17. And measures the length. We are going to assume different variances. Why is that? Whenever they don't mention anything, that's what you have to do. I hope you remember when we did the yogurt thing, we did it two different ways. No assumption, you assume different variances, and therefore that's the test statistic. And you need to calculate a few things to move on. You need sample, standard deviation, mean, size. So size is very simple. N1 is 15 here, N2 is 17 here. The rest of them, you put it into a calculator or Excel and you get the information. So this you don't have to do by hand. However, you remember the formula, I hope. And you come up with those. X bar is summation of x over n, and standard deviation is square root of x minus x bar quantity squared over n minus 1. That is x bar. All of them have to be done. So H0 mu1 equals mu2. We want to see if they are different. We are not saying it's larger or smaller. So mu1 is not equal to mu2. That's the claim for this ecologist, and it makes it a two-tailed test. We use this formula to find test statistic, and we have all the information we need. So we plug in the information into this formula. And test statistic becomes 2.8022. Alpha is 0.05. Degrees of freedom for this one is 15 minus 1. For this one is 17 minus 1. We choose 15 minus 1, smaller of the two, which is 14. Again, without the technology, that's how it's done, because the formula is pretty complicated, as you recall. And so we look up the table and we get plus minus 2.145. To make a decision, we go with the graph. Take a look at the graph. So negative 2.145, positive 2.145, and test statistic of 2.8 is way larger than this, puts us way into the rejection region, reject H0. Now go back to the first step. If we are rejecting H0, what are we not rejecting? H1. We are not rejecting the claim. The claim becomes true. There is enough evidence to support the claim that the mean length of these snakes differs in these areas. It is larger in the unpolluted areas since test statistic is positive. By the way, if you were to make a decision, since this is positive, makes it larger. If it's negative, makes it smaller if you were to make a decision. But for sure, they're different. Now, as far as technology is concerned, we go with two sample t-tests. We put the information. Okay. And it gives us the following. So I'm just showing you the information that has been resulted from the data. Calculator uses a different degrees of freedom, which is this formula. I have already mentioned it to you. If you were to calculate it, you would get that. And take a look at this one. What do we see here? We see the test statistic, which is the same or very close. Degrees of freedom, which is way different than that. The p-value is less than alpha, and it results in the same thing. Reject H0. So critical value alpha is 0.05, degrees of freedom is 29. Round down always. So this one, if you go from the table to find this degrees of freedom, you round it down always. 29 point something, you go with 29. From 29, we get plus minus 2.045. Remember, over here, we had minus 2.145, which is different. Again, if you go with the critical value. As far as the p-value is concerned, we have a point, this number, and let's say we stop here, 8 changes to 9. That's why I put 0.009, which is definitely less than alpha of 0.05, which means the same result, reject H0.